Hello everyone, here's the lab lecture for experiment 5, and in experiment 5 we're going to identify a compound that could be either carbonate or a bicarbonate. Okay, so in this lab the learning objectives are going to be learn how to safely use and adjust a Bunsen burner, because we're going to be using a Bunsen burner to cook our sample, and then we're going to learn how to perform and interpret a flame test, and also we're going to use mass relationships among substances involved in a chemical reaction to identify an unknown. And then at the end we are going to make a product, and then we need to find out how to find the theoretical yield of a reaction, and thereafter what is the percent yield of our reaction. Okay, and then the 4 unknowns that will be given to you is going to be sodium bicarbonate, NaHCO3, that also calls as sodium hydrogen carbonate, and sodium carbonate. So we have 2 sodium compounds, sodium hydrogen carbonate and sodium carbonate. And we have potassium hydrogen carbonate or potassium bicarbonate or potassium carbonate. These are the 4 unknowns. You will be given them as unknown 1, 2, 3 or 4. You will not know which compound you are getting when you get at the beginning, but then at the very end you're going to figure out what is the unknown that is given to you. Okay, so how do we find whether it is a sodium or potassium? To find out that, we're gonna perform a flame test. Okay, so the flame test will be performed in order to find out whether you have a sodium or a potassium. About the flame test and how a compound or a metal gives color to us, we're going to learn about that in detail in chapter 7 and when we are doing experiment 11. Okay, basically atom, when you expose it to a very high energy like a flame, now we all know that atoms carry electrons, so these electrons get excited and goes to a very high energy state, but at the high energy state they are not going to be stable, so it want to come back to its original ground state. So when it emits, or when it comes back, it emits a color characteristic to that element, because each element has different amounts of electrons. So for sodium, that color is yellow. Flame test will give us yellow if it is a sodium, and the flame test will give us a violet color if it is a potassium. Basically, it's the same concept that you are seeing when you watch fireworks. In the fireworks, you see different colors, like the purple, it means violet, that means you have potassium in it. And then if the color of the fireworks is yellow, that is a sodium containing compound. And you can have red, and red could be due to the lithium and strontium, and then you can see beautiful blue-green color, and that is due to copper. So the flame test also, it get excited with the high energy, and then when it comes back to the ground state, it emits a radiation characteristic to the metal ion involved, and then that's how you see those colors. Okay, so that's about little bit about the flame test and then the colors. So first thing what you're going to do is you will be given an evaporating dish or a crucible. Evaporating dish is something like that it's made with porcelain, because we can heat to a very high temperature. And then some campuses we use porcelain dish like that, we call it as a crucible, and then the crucible has a little pout over here, and then you can put a watch glass on top of it. And some campuses we use a crucible like this, and then you can have a lid on top of that. Okay, so either case it doesn't matter, so you can use whichever you want or whichever available in the campus that we are performing this reaction or the experiment. So you're going to put your carbonate or the bicarbonate into a evaporating dish. So this is the evaporating dish, and this is how the crucible look like. And when you watch the virtual video, you can see what it's being used. Okay, First thing is you're going to get the mass of the evaporating dish and the water glass together, or the crucible and the lid together. And then you take your unknown, it could be the bicarbonate, carbonate, potassium or sodium, and you take about 0.5 grams. Maybe first you can weigh it in a weighing board, and then you transfer this 0.5 gram of your unknown into the evaporating dish, and you're going to get the mass again. That's going to be your data B, meaning your unknown compound and then the evaporating dish and the watch glass. Okay, and then when you do that, you put it in the crucible or evaporating dish and you're going to heat it. So you have your stuff inside here, your compound, and then you put the lid and then you use a Bunsen burner to heat it. Okay, so it's gonna heat. And when you heat, what happens is if you start with a hydrogen carbonate, hydrogen carbonates are not stable for the heat. It's going to decompose. In the presence of the heat, it would decompose to metal carbonate, water and carbon dioxide. Since we don't know which metal we have in our compound initially, to do the calculations and show you what reactions involve, instead of the metal we are using it as X, hydrogen carbonate. Okay, X, that is what it means. X could be sodium or potassium. So when you heat it, you're going to be heating it about 10 minutes. And then through the little opening over here, any carbon dioxide and any water generate can escape. So at the very end, after 10 minutes or so, when you get the mass of the evaporating dish and then the watch glass, what you would end up is having the metal carbonate. Because if you started with the bicarbonate, when you heat it, it decomposes to give you metal carbonate, water and carbon dioxide. Okay, let's say you started with a carbonate. Initially, it could be sodium carbonate or potassium carbonate. Now you can see if you had a hydrogen carbonate, what you are left is with a metal carbonate, meaning that no matter how long you're going to be heating up, metal carbonates will not decompose further. They are heat resistant, so they are stable for the heat. So if you started with a metal carbonate, you heat it, and then you will, at the end also, you will get the same solid. So there won't be any important change or major change in the mass. Okay, the reason that we are doing the initial heating is by the mass loss, we should be able to identify whether we have a hydrogen carbonate or just a carbonate. You can see if you have a hydrogen carbonate, since you are making water and carbon dioxide, that's a considerable amount that was in your original compound. So the percent mass loss is going to be more than 25% if you had a metal hydrogen carbonate to begin with. If you have a carbonate also, you will see a certain amount of mass loss that could be below 25%, but that mass loss is due to any water that absorb here due to the moisture in the environment, or some unknown gaseous compounds that stuck inside the metal carbonate. So those things can get evaporated due to the high heat. So that's why you would see, if you are going to see any mass loss, for the metal carbonate. Okay, so everybody understand the reason that we are doing the first heating is to identify whether we have a hydrogen carbonate or a metal carbonate. Okay, and in the meantime, we can expose all 4 unknown compounds, meaning your unknown compound that you get, we can expose it to the flame test. And by the flame test, if the flame test gives us a violet color, we know your initial compound is a potassium compound. And if you get a yellow color, then we know your compound is a sodium compound. So by the flame test, you know whether your unknown metal is potassium or sodium, and from the mass loss, you can identify whether you have a hydrogen carbonate or just a carbonate. That is the reason for our first first heating. Okay, so you heat it. You're going to be watching your virtual video and you see all the experimental detail, how it is being heated, how it need to be handled carefully when you're heating it, and how long you need to be heating it, how to handle when the hot crucibles, and also when you are getting the mass after a heat, you want to make sure that you let it cool to room temperature before you take it to get the mass from the balance. One thing is you're gonna burn yourself if you try to handle a hot evaporating dish. So you want to make until it become to the room temperature where you can touch it. Okay, so what are we gonna do next? And the next, so after the first heat, irrespective of whether we had a bicarbonate to begin with or we had a carbonate to begin with, everybody will have a carbonate in your evaporating dish or your crucible. Okay, now we're gonna react this with hydrochloric acid. Okay, so we are going to react this with hydrochloric acid, and then this is how the reaction takes place. So you take your evaporating dish, let it cool before you do this step. Okay, so you have your carbonate. Let's say you have X2 carbonate, and to this you're going to be adding about 25 drops of 6 molar hydrochloric acid. Drop wise, by drop you're going to be adding, okay, with a pipette. And then when you are adding it, you will see some bubbling, some gas evolving, and see what's happening. So the metal carbonate, when you add hydrochloric acid, what happened? The metal and the chloride get together to form metal chloride, and then the hydrogen and carbon dioxide going to form water and carbon dioxide. So carbon dioxide is a gas, so that's the bubbling that you're going to see, and then the water also going to evaporate as a steam. Okay, so once you add 25 drops of hydrochloric acid, by that time you will see this carbonate will dissolve. If it doesn't dissolve after adding 25 drops, you can add another 5 more drops to make it to dissolve. By that time it should be soluble, and then you take this back to the Bunsen burner and then you're going to heat it. But before you heat, you want to make sure that you put the lid, okay, watch glass, and then you gently start heating it, because now you have a liquid here. That liquid can splatter. So, and then also you can lose your compound, and then if it splattered too much, you know, if there is a leakage in the opening, so it can, you know, spill everywhere. So you want to make sure you control the flame of the Bunsen burner. Heat gently at the beginning until all the liquid is gone, because your liquid is going to be hydrochloric acid. Now it's going to form water and carbon dioxide. Water and carbon dioxide both are gases, so you want to make sure that the lid is not completely closed, but you want to make sure that there is an opening where you can escape all the gases. And you heat it carefully for about another 10 minutes, and until all the liquid has been gone and you have a white solid at the end. So the white solid that you're going to form is the metal chloride. If you started with potassium, it would be potassium chloride. If you started with the sodium, it would be a sodium chloride. Okay, so your X represent either potassium or sodium. So after it's completely dried, after all the liquid's gone, so you have a white solid, you're going to take it from the Bunsen burner and then you're going to let it cool, okay, until it become room temperature where you can touch safely. And then you take both the crucible and your evaporating or the lid or the crucible and the lid, or the evaporating dish and the lid together. Along with the product, you're going to go ahead and get the mass again. Okay, so those are the data you're going to get. So the first data going to be A, which is going to be, so the data that you're going to, come on, look at that. The data you're going to get is mass of the empty evaporating dish and the water glass. That is before you put your stuff in it. 51.9676, and then the mass of the dish and the watch glass with the initial solid about 0.5 grams, and then you're going to get the mass again, and then you heat it. So after the first heat is going to be your C. Mass of the dish, watch glass, sample after the first heating. The data is given, and then you add hydrochloric acid, and then you heat it. That is your second heat, and you get the mass again. So you're going to be getting 4 data for this experiment. Okay, these are the data that was given to us from the experiment that is being done. So I wrote it down over here. Okay, so how do we find the mass of the initial solid? Mass of the initial solid is going to be B minus A. Right? It's going to be B minus A. What's that going to be? Okay, let's see. 52.9676 minus 52.4842, and that is 0.4834. 0.4834. And then the mass of the solid after first heating. Now everybody will have a carbonate, because everything, irrespective whether you have a hydrogen carbonate or you had a carbonate, everything is now converted to carbonate. So what's going to be the mass of the solid after first heating? How do you find out that? That's going to be C minus A, right? C minus A. That is going to be 52.4703 minus 51.9676. That's 0.5027. And when you are putting these numbers, make sure you put your units. Okay. And then how do you find out the mass loss due to first heating? What is the mass loss? Now from the E we know the mass of the initial solid. F we know what is the mass after the first heating. So what is the amount of mass loss due to first heating? How do you calculate that? Which letters can we use? E minus F is the mass of the initial solid. After the first heating, it is F. So it's going to be E minus F. E minus F. So E is 0.5027 minus 0.4834. That's 0.0193. 0.193 grams. And then we need to find out what is the percent mass loss. So we know the mass loss. How do you find the percent mass loss? That's going to be G. You divide by the mass of the initial solid, which is E. You get that number, and then you multiply it by 100. Meaning G is 0.0193, and then you divide it by the mass of the initial solid, 0.4834, and then you multiply it by 100. That's 3.98. 3.98%. Now, was the initial solid a carbonate or a bicarbonate? Remember, if the percent mass loss is greater than 25%, that's a hydrogen carbonate. If the mass loss is less than 25%, that is going to be a carbonate. If it is more than 25, it is a bicarbonate. So ours is about 4%. Do you think it's a carbonate or a bicarbonate? It is a carbonate. Was the initial solid a bicarbonate? No. And the flame test was given, the color of the flame was given as violet. If the color is violet and it is not a bicarbonate, what should be the formula of your assigned unknown. Color is violet, it's potassium, and you said it's a carbonate, so then it should be potassium carbonate. Correct? That's how you find out the chemical formula of your assigned unknown. And then the mass of the chloride. Mass of the chloride is what you have at the very end. Remember, in the evaporating dish, after you add hydrochloric acid, it reacts to give you HCl, metal chloride. So how do you find out the mass of the chloride? Actual yield from our experiment, that's going to be D minus A. So D is 52.4875 minus 51.9676. That is 0.5199. And then we need to find out the theoretical yield of the chloride. How do we find out the theoretical yield? Meaning, even before we perform the experiment, we can find out how much chloride we are supposed to make depending on the molar ratio, and also depending on the initial compound that we took. Now we know it was a potassium carbonate, right? So we can go ahead and see how to calculate the theoretical yield. Okay. Now, if the unknown originally contained the carbonate ion, the overall reaction after both heating is metal carbonate plus 2 hydrogen chloride, giving us metal chloride, water and carbon dioxide. Remember, we did 2 heatings. So the first heating was, we took the metal carbonate, you heat it, nothing happened. And then the second heating, we took that metal carbonate, you add hydrochloric acid, it forms metal chloride, water and carbon dioxide. So the balance equation would be, there are 2x, 2xCl, and then now this became 2 chloride, so then the hydrochloric acid needed to be 2, and then water and carbon dioxide 1:1 ratio. So this is the overall reaction if you had a metal carbonate to begin with. So we can find out theoretically the amount of metal chloride can be formed from the original amount we took metal carbonate. We have done so many questions like this. Even you have done your exam with solving many problems similar to this. So we start with the grams of metal carbonate. That was originally about 0.5 grams. But from your calculations, you can see what is the exact amount you got. That's going to be your B minus A, where you have the mass of the initial solid is E. So you're going to be using 0.4834 grams. In other words, what you have in E. So this is how you calculate. You start with E grams, okay, and then that's the mass of metal carbonate. And then we need to convert to moles using the molar mass of the metal carbonate. So since our compound is potassium, we use the molar mass of potassium carbonate. So that's going to be M potassium carbonate. You can calculate the molar mass. I'm not going to do it for you. So you have also can actually participate in doing the calculation. So I'm going to leave like mass of the metal carbonate, which is potassium carbonate in our case. But if you had used sodium, then you will use the mass of sodium carbonate. That's 1 mole. And then you use the molar ratio. 1 mole potassium carbonate, K2CO3, react to give you how many moles of hydrochloric acid? 2 moles, not hydrochloric acid, sorry, metal chloride, 2 moles metal chloride, 1:2 ratio. This is going to be our product, metal chloride. And then we need to find out the theoretical yield of the metal chloride that we can obtain with the taken amount of the metal carbonate. So from metal, 1 mole XCl, and in fact we know what is X, that's going to be KCl. So we can change X to KCl. Instead of X, we can do K now, since we know it's potassium, KCl. So 1 mole KCl is the molar mass of KCl in grams. Okay. So take the E, which is 0.4 something, and then use the molar mass of potassium carbonate. Use the molar ratio, use the molar mass of potassium chloride. This will give you the theoretical yield. Okay. And this is if your sample that you took was a metal carbonate. But what if you have your original compound contained the bicarbonate? So then remember the bicarbonate ion, first we heat it and then it became the metal carbonate, carbon dioxide and water. And then we take that metal carbonate, add hydrochloric acid and gave us a metal chloride, carbon dioxide and water. Okay. And then the reaction, when I cut and paste, it didn't work. So I'm gonna delete it. I'll write it for you guys now. Okay. No, so what are the two reactions that involve? Remember the metal bicarbonate, that is XHCO3, and you just heat it, nothing added in the first time. You heat it, we give the heat symbol like that, a triangle, and then when you heat it, it becomes X2CO3 plus carbon dioxide and water. If you had a hydrogen carbonate, and then we need to balance this. There are two hydrogens, and then we have 2 carbon, so we need to make sure that it's 2 carbon. So, and then what about the water? Do we need to change the water? 2 hydrogens, 2 hydrogens. We don't need to do the 2 carbons because we already have a carbon right there. Okay, you don't need that. Okay, because here we have 1 carbon, here you have 1 carbon, here you have another carbon, so the 2 carbons, so now you have 2 carbons, 2x, and we have 3, 4, 5, 6 oxygens, 3 times 2, 6 oxygen, 2 hydrogens, 2 hydrogen. Now it is balanced. So this is what happened when you first heat. And then you took that X2CO3, metal carbonate, and then you add hydrochloric acid, and then this became XCl plus carbon dioxide plus water. This is your second heating. Now whoever used metal bicarbonate had to use both of these reactions to get to the final product. And we can balance this one, that's 2XCl. And then you can put 2 right there. Now it is balanced. Okay. Now if a reaction involves 2 steps like this, to get the overall reaction we need to add them together. So when you add the 2 together, you can cancel the same compound if you find it in the product and the reactant sides. So 2XHCO3, 2X, metal bicarbonate, metal 2XHCO3 plus, you see here in our 2 reactions, we have X2CO3 as a product and then the second reaction X2CO3 going to use as a reactant. So since you find the same compound in the same amount in the both sides as a reactant and the product, when you add it up you can cancel it. Okay, and then a reactant side we also have 2 HCl, and then from the product side we have 2 metal chloride plus 1 plus 1 2 carbon dioxide plus 1 plus 1 2 water molecules. So whoever going to have the hydrogen carbonate, this last reaction that I just draw would be the final reaction. Okay, and you can see all of these have coefficient 2, 2, 2, 2, 2. So then what you can do is, since everybody has the same coefficient, you can simplify it to get to this equation where you have 1 to 1 to 1 to 1 to 1 ratio. That is the overall reaction if you had a metal bicarbonate to begin with. Now we can also go ahead and calculate the theoretical yield, the amount of metal chloride that could be formed from the given amount of metal hydrogen carbonate. Again, if you started with the hydrogen carbonate, you use the grams hydrogen carbonate. Let's say that's the amount that we have at E in our data table. E grams, that's the grams XHCO3. So 1 mole of XHCO3 going to be the molar mass of XHCO3. And then you use the molar ratio, 1 mole metal hydrogen carbonate gives you 1 mole XCl, molar ratio 1 to 1, and then 1 mole XCl would be the molar mass of XCl in grams. This is how you're going to calculate the theoretical yield of the metal chloride if you had a metal hydrogen carbonate to begin with. Normally, if you perform this reaction in the lab, you will only have to do the theoretical yield calculation for the unknown compound you used. You don't have to do both, but I showed you here both how to calculate that. Okay. So, okay, so let's see. Now, I just showed you how to calculate the theoretical yield of the chloride. Okay, for your J, and then the percent yield. How do you calculate the percent yield? Percent yield normally is the, you guys know what is the percent yield, right? It's the actual yield over theoretical yield. Percent yield is going to be actual yield over theoretical yield, and you multiply that by 100%. So which one is our actual yield? Our actual yield we found out that is in I mass of the chloride. You take that I and you divide it by the theoretical yield, which is J. I over J times 100 will give you the percent yield. Okay. I did not do the theoretical yield calculation, but I showed you how to do it. So you can perform that calculation and put the answer in J. Okay. And in fact, here you have to show how you calculate your theoretical yield. Write the balanced chemical equation for the overall reaction that you observed for your unknown in the space provided below. Now, in order to do that, remember you figured out that you have potassium carbonate. If you had a carbonate, what is the overall reaction for carbonate? The first time you heated, nothing happened, became a carbonate. So your overall reaction is going to be potassium carbonate plus hydrochloric acid, giving you potassium chloride plus water and carbon dioxide. That's going to be your overall reaction. And then use this balance equation and the mass of unknown to calculate the theoretical yield of metal chloride in your overall reaction. I showed this to you, right, in the previous slide, how to do this one. So you can refer to that. Remember, I put E grams and then I did it for the metal carbonate. So use that calculation to do your calculation for this part. And then calculate the percent yield. I showed you percentage yield is also actual yield over theoretical yield times 100 is the percent yield. So show how you get the percent yield. Okay, that's about the experiment. So the pre-lab assignment, I'll do a separate video. I hope you understand this. Okay.